friends, this is Sreenivas Arella, architect in Big Data at Locuz. Once again, welcome back to webinar series on AWS services. In this episode, I will take you through one of the AWS services, AWS step functions. We will try developing parallel ETL pipelines using Amazon step functions, AWS Glue, and Amazon S3. Now let's try understanding what are step functions. AWS step functions is an Amazon provided AWS service where we can develop or orchestrate or stitch together multiple AWS services seamlessly without any hassle in order to accomplish certain tasks. With AWS step functions, we can now build distributed applications using visual workflows. In other words, it allows us to stitch together multiple AWS services in terms of workflows. Now, how these step functions work? Under the hood, step functions is a state machine which is comprised of series of steps. In fact, a step in step function is its primary abstraction. We need to configure a step function in AWS services. A step function configuration constitutes a map of all possible steps and the transitions between them. In order to configure this state machine, we use a language called Amazon States language. With this brief introduction on AWS step function, let's try developing an orchestration of parallel ETL pipelines in AWS. Now, we will develop a state machine using step functions that takes care of executing two ETL jobs in parallel, and then it goes for executing a job that joins these two data steps that can be used for further data analytics. The state machine that we are going to develop will look like the one shown in this picture. We will develop a series of steps in the state machine, and we branch the steps in such a way that one branch takes care of extraction, transformation, and load process of sales data, and the other branch takes care of extraction, transformation, and load process of marketing data. This state machine has a step that waits for the completion of these two ETL jobs. After the successful completion of these two ETL jobs, it goes and executes a step called join, where it kicks off a job that merges these two data steps into one data step, which can be further used for data analytics. After the successful completion of this join step, our state machine terminates. Why do we delay? Let's jump into AWS console. We are at AWS Management Console. We will use two publicly available Amazon QuickSight datasets for this webinar. One dataset is sales dataset and the other dataset is marketing dataset. The sales dataset contains all the records related to sales opportunity, and marketing dataset contains all the records relating to marketing metrics. I have created two S3 buckets and uploaded these two datasets. Let's see them in the S3. So I have created step function sales data, and also I created step functions marketing data. And in step functions, I created raw folder and I created processed folder. And I uploaded the sales data in raw folder. Same is the case with marketing dataset. I created two folders in marketing bucket. One is raw, the other one is processed. So now what I'm going to do is I will create a crawler, each for sales data and marketing data, and I will create a glue job. What that glue job is going to do is it picks up this sales data set, and which is in .csv format, and it converts it into Parquet format. So the basic purpose of this webinar is to understand the capabilities of step functions. So our ETL job, our Glue ETL job will do conversion of .csv file into .parquet. See, we can take complex scenarios also. AWS Glue is capable of doing complex aggregations on a data set. So you take a data set, perform a lot of transformations, a lot of complex aggregations, and create a data set in the desired format. So that also can be done. But for this webinar, we will stick to converting the .csv format into .parquet format. So I will take you to AWS Glue. See, we don't have databases and we don't have any tables. So let's create a crawler. Add crawler. So give a name. So I keep it as sales crawler. And then data store. Specify the path of the Amazon S3. So sales data. And in the raw bucket, we have sales data. So select raw folder. Then click next. Do you want any another data store? No. So we need to create a IAM role that takes care of accessing the Amazon S3 reading and writing. So you can create or you can choose the existing one. So I will choose the existing one. Then click next. So run on demand. And here, because we don't have any database, we need to create a database. Add database. So I'll keep this as sales data. Create. We don't need any prefix. So click next. Keep all the other configurations default and then finish. So our sales crawler is ready. Let's run it now so that it reads the .csv file and creates a metadata and keeps it into the table. So run it now. So it takes some time for the crawler to complete. So meanwhile, we will create another crawler for marketing data. Add crawler. So I'll keep the name as marketing crawler. Then click next. Choose the data store from S3. So this is my data store available in raw data. And click next. Don't need any other data store. Choose the existing IAM role or create the one as you wish. So click next. So let's run it on demand. Then next. So for marketing data, we don't have a database. So there's only a sales database available. So let's create a database for marketing data. Marketing data. Create. Keep all the other configurations default. Click next and finish. So your crawler is ready. So yeah, sales crawler is I think it's almost finished. See this, it added a table. So it takes some time for this to get finished. Till that moment, I will pause the video. Once this is complete, I will come back. Yeah, crawlers have completed and they are now in ready status. Each of them have added one table. You can also see the tables here. Metadata for the sales data and marketing data. Now we need to create ETL jobs. Keeping time in view, I have already created 2 ETL jobs. One for sales data, the other one for marketing data. Sales data takes the file from .csv file from S3 bucket, transforms it into Parquet file and saves the formatted file into S3 bucket. Same is the case with marketing data. Now we have completed the setup of S3 and setup of AWS Glue. Now we will go and start coding for AWS step functions. Click on Get Started. It takes you to some examples. Come back and click on State Machines. So in step functions, we can create either state machines or we can create activities. I will tell you later what is an activity. We already know what is a state machines. So let's first create state machine. Creating state machines is two steps. One is you need to define the state machine and then you need to specify the details. While defining the state machines, either you can create your own code or you can use the existing sample templates or you can run existing sample projects. So here we will be developing our own code. And there are two types of state machines. One is standard one, the other one is express. Standard workflows and express workflows. There are subtle differences between standard workflows and express workflows that we can discuss in some other webinar. But as of now, I will go through with standard workflows. Now this is the place where we define our state machine. So it already gives you some sample code and some sample visual workflow. What I'm going to do is we will be starting afresh. So I will remove everything out of it and then we'll start writing our own state machine code. Let's start coding. Just give a brief description of what this state machine is about. State machine to perform parallel ETL and then specify where the execution should start. So I will give the step from where the execution should start, and then you should specify all the states. You should define all the states, and as part of that, the first state will be reprocess. Basically, in the pre-process step, you can include logic such as where you will be waiting for data to come in S3 buckets of that sort. Such logic can be included here. Now in this webinar, we are not including that logic. So let's keep it simple. So as this state is not doing anything, I'll just say pass. You can also, if wanted, you can include a comment for this step. So execution starts from here. And then I should connect this step to next step. So the next step is going to be perform parallel ETL. So copy this. So define the next step. The next step actually needs to take care of parallel processing, and hence we should define the type of this step. Type of this step happens to be parallel, and because this is a parallel, we need to specify different branches, and this branches is a list of different steps, and I will include the code little later. So I will specify from here where it should go. So from here it should go to join datasets. So let's put the code here. Now this is one branch and this is code for second branch. So this branch will take care of sales data ATL. So this branch, I should tell where from it should start. So start at prepare sales data ETL, and it will have its own states. So prepare sales data ETL, and this activity is this step is the beginning step for the sales ETL branch. So I should specify type, and in this tab we will not be doing anything, so I will pass it and then next where it should go. It should go to submit sales data ETL job. So copy this, put comma, include it. Now specify what type of step it is. So type, it's going to perform a task for us. So I'll say task, and then what sort of task it is going to perform. It's going to submit job for us. So once I put quotation marks, automatically this window pops up. So here you need to specify Amazon resource name, that is glue job. So we have this resource, a function start job run .sync, which helps us submitting the job. And if you use .sync, what happens is this particular step waits for the job till it gets completed. Then for this job, you need to specify what is the job that needs to be submitted. So that I will specify through parameters. Okay, I need to put a comma here. Specify the job name. So we will get the job name from here. So sales data ETL job. Copy it, paste it. That's it. And then after that, you need to specify where it should go. So once the job is completed, I can end this step. Or I can say it should go to next step. So it's up to us. So we have completed parallel ETL process for sales data. We need to code for marketing data. So what I will do is I will make use of the existing code. I'll just copy it and paste it here, and just change the names wherever required. Marketing marketing. And here we need to specify the marketing data job. So everything is set, and here we need to specify the job for sales data ETL. Here we have, copy it, paste it. So now we have created the branch for sales data ETL and branch for marketing data ETL, and we also specified where it should go from this branch. Let's start creating this. So we have not written any logic. We have not written any job for AWS Glue where you're going to join the two data sets. And that's why for the moment I'm giving this step as pass, and then I will specify next where it should go. It should go to terminate state machine. So now here we will write the logic for terminate state machine. Here also we should specify what type of step it is. So this is the final step, and we're not going to do anything here. I have specified it as a pass, and then if you want you can also include comment and say state machine terminates here. So include and so yeah. Set, all set. So we have written the complete code for ETL pipeline, and if you want to see that visually here, you just have to click this button. See this, how beautifully it's depicting the entire workflow. So now that we have completed this, so let's click next, give a name. So this is parallel ETL pipeline. So automatically state machine will create new role based on the services you have used inside the state machine code. So you need not bother about creating the IAM role and all. So keep everything as defaults, and then click create state machine. So this will create a state machine. So now our state machine is ready for execution. Now we can start executing the state machine. Just click start execution. So there's nothing we need to provide as input. So click again start execution. So it shows that our execution has started. If you come here, See this? This process is successfully executed. So whenever the process is successful, the color will be green. So our first step is completely executed successfully. You see this? We have not sent any input, and also it's not getting any output. Here also the same thing, but here it is this step is the step which is actually where ETL jobs are getting submitted. You see, the job is in progress, and this step waits till that particular job gets completed. That we can observe even in the AWS Glue console. Let's go into AWS Glue console. In the ETL jobs, select sales data and then see this. See this? The job is being submitted by the step function. Same is the case with marketing job also. Select marketing job and then observe the history. See this? The job is getting submitted, and it's gonna take some time for getting these jobs completed, and by the time the step function also turns into green. I will pause the video till the job completes, and we'll come back once the job gets completed. Now verify the job whether it's completed or not. Click on this. See this? The job is succeeded now. Also check the next job, marketing job. Marketing job is also succeeded. Now check whether we got the file in processed folder or not. Sales data, processed folder. See, market file is being created. Let's check for marketing data. See, the file is created even for marketing data, packet file. Now let's go to step functions and see the status. Succeeded. That means the step function is completed. So see this, the state is being turned into green. So we have input and output. So output, it received the job status, and same is the case for marketing data. It received the status for marketing data, and we can also observe the series of execution events in the execution event history, how the steps were executed. See, finally the execution succeeded. We can also create activities. So far what we did was, in the step itself we have submitted the ETL job, and we waited for the job to be completed. We asked the step to wait till the job gets completed. Instead of that, we can also write an activity where that activity takes care of polling the job status, getting the status and returning it to the step, instead of asking the step to wait and then get the status of the job. We can also create activities where they'll go and do the poll job, like they'll work as workers, which will help us to find out the poll jobs status and returning that status to state machine, and further taking up the completion of the tasks of the state machine. So state machines, step functions are so powerful that we can orchestrate a lot of tasks within the step functions. Thanks for watching this webinar. We will meet once again with new concept. Please leave your comments and subscribe to our YouTube channel. Thank you.